Today I'm going to walk through how I made a steel collar for my robotic arm. So this is a steel collar for the robotic arm I recently built. It mounts to the NEMA 23 gearbox output shaft, and bolts to the actual arm itself from the inside to transfer the shaft's torque to the arm. Taking a look at the CAD, we can get a better idea of how it works. The collar is located here on the inside of one of the arm plates. It slides over the shaft and has a bolt that presses down into the flat of the keyway. It's not the best way to do things, but I don't have a broach to put an actual keyway slot in, and this will definitely work just fine for the relatively low loads it's seeing. Given the forces acting on such a small part, I'm more inclined to make it out of steel rather than something softer like aluminum. Looking at the part in Fusion 360, I'm using a piece of stock that's the same thickness of the final part, so it'll be mounted flat in the vise like this, and I'll profile it out from the top first. I'm using a 4mm end mill, and I'll start by boring out the inside holes. I don't want to plunge too fast and risk melting or breaking the end mill. After the holes, I'm going to contour the part all the way through, but I'm going to place 4 tabs to hold the part in. I don't want it to break loose and whip around, damaging itself or the end mill. After that's done, I can break out the part and remove the tabs, and then flip the part up on one side to machine a small flat, and then bore out the hole for the set screw. Right now I have a cheap Chinese 4mm end mill for this job. I don't know if it's carbide, I doubt it's even coated. It literally cost a few dollars, so I'm not expecting much performance or longevity out of it. So as I'm cutting, I realized I didn't quite get the material seated down on the parallels correctly, so they began to vibrate and slide out. You'll see me here trying to pull them out and drop them on the machine bed. And then later on this turned out to be a bad idea, because the parallels slid down and jammed in the bed. That caused the machine to stall on the y-axis, which sent the mill plunging into the material. Somehow, my end mill managed not to break, and the part is still fine inside the material, so I can reprobe and restart the contour over. Once that's done, I have the part ready to pop out of its tabs. You can see it didn't quite break the material, but that's because the metal sort of pushed outwards, maybe due to having a dull end mill. Anyways, not too big of a deal since it's like paper thin and I can just stab through with a flat screwdriver. Now that I've cleaned off the tabs, I can see a clear problem, which is that the second time I ran the contour, it was slightly out of position and left a little lip on one side of the part. The reason for this I realized after is that when I probed the part for the contour the second time, I probed the part when it was wet and had chips on it. That is something you should never do because liquids can make contact with the probe and the material before they touch to give you a false reading, and of course chips can bridge that little gap and give a false reading as well. So one of those two probably happened because I know that the dry probe is accurate to about 0.01 millimeters, but I was rushing and I didn't think to clean it off first. I could start this job all over again, but realistically this lip won't cause me any problems, so I'm just going to continue with it despite it being a bit ugly. Moving on to the last operation, I have the part mounted sideways and the end mill loaded. Here we're just facing down and doing a little bore. After that's done, I can pop this little centerpiece out, which I didn't catch in the cam simulation. I really should have paid more attention because things like this can easily break a small end mill. Anyways, after that's done, I need to drill this completely through and then tap the hole for an M5 bolt. After everything is done, here's the final part ready to install. So as always, hope you enjoyed, hope you learned something new. See you in the next one.